Welcome to Tech Golly Podcast.
The way we produce and consume energy is undergoing a fundamental shift. This transformation is moving us away from centralized power plants towards a more distributed energy system. Distributed generation, the cornerstone of this new paradigm, involves generating electricity close to where it's used. This approach leverages a diverse array of energy resources, including solar, wind, and combined heat and power systems. Imagine a future where electricity isn't solely reliant on distant power plants. Instead, picture a network of homes, businesses, and communities generating their own clean energy. This is the promise of distributed generation, a future where energy production is democratized, resilient, and sustainable. This shift is not just about changing technologies. It's about reimagining our relationship with energy. It's about empowering individuals and communities to become active participants in the energy transition. Distributed generation is key to building a cleaner, more resilient, and equitable energy future.
One of the most compelling benefits of distributed generation is its ability to enhance energy resilience. Traditional centralized grids are vulnerable to disruptions, whether from natural disasters, equipment failures, or cyber attacks. When a central power plant goes down, a wide area can be plunged into darkness. Distributed generation offers a powerful solution by diversifying energy sources and creating redundancy in the grid. When paired with energy storage, distributed generation can provide backup power during outages. This is particularly crucial in the face of increasing climate volatility, where extreme weather events can disrupt centralized power grids. Moreover, distributed generation empowers communities to become more self-sufficient in their energy needs. This localized approach reduces reliance on long-distance transmission lines, which are also prone to disruptions. By strengthening the grid at the local level, distributed generation fosters greater energy independence and security for communities.
Distributed generation isn't just about keeping the lights on, it's also about greening the grid. A significant portion of distributed generation relies on renewable energy sources like solar and wind power. By harnessing these clean and abundant resources, we can reduce our dependence on fossil fuels and mitigate the harmful impacts of climate change. Rooftop solar panels, a ubiquitous example of distributed generation, transform homes and businesses into mini power plants. As the sun shines, these panels convert sunlight directly into electricity, offsetting the need for electricity generated from fossil fuels. By generating clean energy at the point of consumption, distributed generation reduces transmission losses and minimizes the environmental footprint of electricity generation. The environmental benefits extend beyond carbon reduction. Distributed generation can also improve air quality, reduce water usage, and minimize the need for land-intensive energy infrastructure. By embracing distributed generation, we can create a cleaner, healthier, and more sustainable energy future for all.
Beyond resilience and sustainability, distributed generation offers another significant advantage: grid optimization. Traditional grids are designed for one-way flow of electricity from centralized power plants to consumers. This approach is inefficient and can lead to power losses and voltage fluctuations. Distributed generation transforms this dynamic by introducing a two-way flow of electricity. When distributed energy resources generate more electricity than needed locally, the excess can be fed back into the grid. This process, known as grid export, can help meet electricity demand elsewhere, reduce the strain on the grid, and improve overall grid efficiency. Furthermore, distributed generation can help defer or even eliminate the need for costly grid upgrades. By generating electricity closer to where it's used, distributed generation reduces the amount of electricity that needs to be transported over long distances. This can alleviate congestion on transmission lines and postpone or reduce the need for building new ones.
Distributed generation encompasses diverse technologies, each with unique strengths. Solar photovoltaic systems are the most recognizable form. From rooftop panels to large-scale farms, they harness the sun's power. Wind turbines convert wind energy into electricity. They range from small residential models to large wind farms. Combined heat and power systems, or cogeneration, capture and utilize waste heat. This improves energy efficiency by generating heat and electricity simultaneously.
Distributed generation applications are as diverse as the technologies themselves. Rooftop solar panels empower homeowners to generate clean electricity and reduce grid reliance. Home energy storage systems store excess solar energy, enhancing energy independence. Businesses embrace distributed generation to lower costs and reduce environmental impact. From solar panels on factory rooftops to CHP systems, businesses innovate with distributed generation. In rural areas, distributed generation extends electricity access to remote communities. Microgrids bring reliable electricity to these communities, powering homes and essential services.
While the benefits of distributed generation are undeniable, several challenges need to be addressed to fully unlock its potential. One significant hurdle is grid integration. As more distributed energy resources connect to the grid, it's crucial to ensure that the grid can handle the two-way flow of electricity and the intermittent nature of some renewable sources. Equity is another critical consideration. The benefits of distributed generation should be accessible to all communities, regardless of income level or geographic location. Policymakers need to address potential barriers to adoption, such as upfront costs and access to financing, to ensure that distributed generation benefits everyone. Supportive policy frameworks are essential for fostering the growth of distributed generation. This includes policies such as net metering, which compensates consumers for the excess electricity they feed back into the grid, and tax incentives that make distributed generation technologies more affordable.
The future of distributed generation is brimming with exciting possibilities. Advancements in energy storage technologies, particularly batteries, are poised to revolutionize the way we store and utilize renewable energy. As battery costs continue to decline, we can expect to see wider adoption of home energy storage systems and grid-scale batteries that can store excess renewable energy and dispatch it when needed. Grid modernization efforts are underway to transform the existing grid into a more intelligent and flexible system. Smart grids, equipped with advanced sensors and communication technologies, will be better equipped to manage the two-way flow of electricity, integrate distributed energy resources seamlessly, and optimize grid performance. Community-based energy models are gaining traction, empowering communities to collectively own and manage their energy resources. These models foster local energy independence, create economic opportunities within communities, and ensure that the benefits of distributed generation are shared equitably.
Distributed generation is more than just a technological advancement. It's a fundamental shift in the way we think about and interact with energy. It's a vision of a future where energy production is democratized, resilient, and sustainable. By embracing distributed generation, we can create a cleaner, more equitable, and more resilient energy future for all. Imagine a world where every rooftop is a power plant, every home is energy efficient, and every community is empowered to generate its own clean energy. This is the promise of distributed generation, a powerful vision that can transform our energy system and create a brighter future for generations to come.